Hello there and welcome to this Pandas Challenge, day 15 of 30. My name is Valentine and I'll be your instructor. In this Pandas Challenge, you're going to continue your learning journey when it comes to using the Pandas library for data manipulation, analysis, or even just exploration. So let's get started. The first thing that you need to do is to visit the practice resource link that we've shared in the description section. That should take you to a page that looks like what you're seeing on the screen. So feel free, by the way, to pause the video and do that. Once you get to this page, click on the sample practice resource, which should take you to now this particular resource, and then you can get started. Now, it's important to note that if you're an afterwork member or if you want more exercises, more challenges, be sure to become an afterwork member. That will give you access to tons of resources when it comes to just becoming a data scientist or data engineer or practicing skills that make you such professionals. So, just that is something to take into consideration. I will be using a different notebook which will contain lots of challenges, so don't mind so much about that. Once you get to this page, go to File, then Save a Copy in Drive to save a copy of this notebook to your Google Drive. It should open in a new tab, and then you can close down the original copy. Then you use that new copy. All right, once you get to that new copy, the first thing you need to do is to just connect that notebook to Google servers by clicking on Connect. And we're not running Python locally or Pandas locally. We're just using Google Collaboratory, which is a Google app that would you'd access that app through Google Drive. So once you do that, let's run the prerequisite. Just run anyway to import the Pandas library. So we import it as PD, and then we can get started. When it comes to working with data, so coming up with summaries based on larger tables, we can create pivot tables, but we can also create a specific type of pivot tables or summary tables that would allow us to understand the frequency distribution of variables. So for example, if we had a data set that looked like what you're seeing here, it has products information. So each and every record is a product. Each and every record represents information about a product. If we wanted maybe to determine, say, what is the relationship between the different colors that there are or different values that there are in this categorical variable, then we can be able to use what are called cross-tab tables. So how we create them is, we use the PD cross-tab function. So we reference that cross-tab function, and we pass the categorical variable that we want to work with. So for example, if you want to find the relationship between category as well as the different colors, then we can be able to specify first the category, then the second argument or the second input is now the color, the other categorical variable. So in this case, what we will end up getting is a frequency distribution table. So if I run this, that contains category on the left hand side, and on the right hand side we have different colors. You can just have this as a Pandas data frame output by just saying reset underscore index and run that. You should be able to see now you have an output that you can use in different cases. But yeah, so in our case here, we have just a frequency table that contains just occurrences of the different colors per category. So based on this category that you have here. All right, pause the video and then work on the challenge. We have this challenge that you will find here. All right, moving on. In some cases where we are working with raw data, we might want to replace some values, and we can use the replace function maybe to replace values within a particular column or a row. And how we do that, so assuming that we had this example, we wanted to replace, so the color that we have here, we might want to replace what we have as values here with numbers, maybe for answering a research question or for building machine learning models, etc. So how we're able to do that, how we're able to how we are able to perform that replacement, we would first need to create a dictionary, or that would have key value pairs. The key would represent the original value, and the value for each key value would represent the new value that we want. So in our case, we have we want 0 to replace black value and 1 to replace white value. And then we apply the replace function to the column that we want to apply that replacement in, which is the df color. That's the color column. And we can preview the modified data set afterwards. And you can see here in our instance, for the replacements, we did black to be 0, which initially was, and white to be 1. And we can add more key value pairs to be able to sort, or to be able to deal with the rest of the colors. Right, pause the video and then work on the challenge. In some cases, we might also want to maybe search for certain values within columns. So assuming that we had a new data set, this is the data set that we had, and we wanted to just get maybe records where a certain value, it could be that that value could be maybe smartphone. We wanted to get records that have the word smartphone within the description column or any other column. We can use the string, one of the string methods called, this actually called contains function that allows us to just perform that filtering process of checking whether that string exists within that column. So in our case, here we're simply doing Boolean indexing, but our condition, the one that we're defining here, we are checking it for the color column. So for the color column, we want to check for the string black. If there's an existence of the string black in the color column, then we are going to get that, filter that row. And we specify case to false, meaning that we are not really interested in whether the black has to be capital or small. In any instance, we would want to use that record. So, and that's it. We apply that filtering and we display the output which we have here. You can also experiment with now the description column and change the values of either the input, the first one, that's the black value, or even just the case value. Pause the video and then work on the challenge. In some other cases where we are getting, maybe we might want to, we might have maybe a complex research question that requires we combine the values of two columns. So for instance, if we had maybe this data set that contains the following information, again, still about products, and we needed to answer a research question that takes into account of category as well as brand, then what we might want to do is to concatenate or to join those two columns so that we have, let's say, ABC company dash apparel, XYZ brand dash apparel, etc. So how we're able to do that, we just use the normal operators. There's the arithmetic operators, the additional arithmetic operator, the addition operator, and this allows us to combine the values for one particular column with another string as well as the values of another column. The string that we have here just separates the two values, and the output of this operation would be stored in this new column, brand category. Right, run that, and when you look closely, you can see on the far right side we have brand category. It's important to note that you can also use reindex method or those methods that we've learned in the past about ordering. All right, pause the video and then work on the challenge. In some cases where we might want to maybe create visualizations like histograms, and we, those histograms, we might want to create them out of maybe some sort of numerical variable, then we can perform this technique that we're going to learn, which generally entails binning numerical data. So we can decide to create what are called bins and use them later onwards for visualization or for even other use cases. So in our case here, we have this products data set, and what we might want to do is to use the price columns, the price column, to create a bin or to create multiple bins. And we would want to define the bins how we want, like, for example, we would define the bin edges, like, what we have here are the bin edges, and then we have now the name of those bins. So from 0 to 50, that will be one bin. From 50 to 100, another one. For 51, sorry, 200, that will be another one. So, and the labels over here, just the names that we give to these bins, but we give them the ranges that you see here. And then we use the cut function, or the cut method from Pandas to specify or to perform this binning operation, where we specify the column name, the bin edges, as well as the labels. And here in our case, we just want to have the lowest values to be included as true. And we display then the just new column that we've created. So the output of this will be stored in a new column called price bins. And yeah, we display now the columns that we have created and compare with now the original column. So you can see that's what we have here. All right, pause the video and then work on the challenge. In a past challenge, we got to learn how to filter for data using the is-in method. However, we are going to continue practicing. The idea is that to get better at something, we always need to just reuse and continue practicing. And by the way, this is where when it comes to learning a skill, sometimes maybe you might have not used maybe a library, maybe two years ago, or maybe not 2 years ago, maybe you haven't used a library in 3 years. You can always sit in and work on such a challenge and go through maybe 30 days of just learning how to reuse the same tool again if you want. All right, so this is another technique that we're going to learn. Not another, it's still the same one, where we could decide to use multiple is-in functions in our to define our conditions. So this is a filtering operation, but we want to perform multiple. We wanted to check for multiple conditions. So this is the first condition, where we check for whether the categories values, these two values, are in the category column. The same case for the colors list. Black or blue is in the color column. So we check for whether these two conditions are actually true, and if they are true, we retrieve the records for which those two conditions are true, and we display them here. All right, pause the video and then work on the challenge. In some other cases, we might want to ensure that the data that we are working with is in a numerical format. We then can use many techniques. We got to learn about how to replace values using the replace function, but we can also use mapping or the map function to perform this operation. So this actually works similar to almost similar to the string, not the string, the replace function. The only thing here, so assuming that we have this data set still of products that contains products, and we wanted to replace maybe a certain column such as brand with the respective by the way, this just to I think I explained it a bit differently. This particular concept is not really about having a data set that has numerical variables, but this just involves replacing values that are not necessarily standard with now standard values. Like, for example, the brand Samsung, that value, when it comes to analysis or maybe stock analysis or trading, might be represented by SAMS, or Apple would be replaced by APPL. So in such situations, we might want to use, still you can use the mapping method or even replace function for that. But for ease of convenience, you would need to, you can use mapping method where you might decide to define the old values and new values as key value pairs in a dictionary, like brand mapping. And then once you do that, you apply now that to the column that you want. You could have also done that, using the replace approach that we have used in the previous section. But this is just a way of just knowing that this technique can be also handy in your case. All right, pause the video and then work on the challenge. Oh, and not even that. Let me just even reload this so that you see brand SMS. You can see. Right. Yes, I hope you paused the video, worked on the challenge. Then let's continue. Group by with apply. So in some cases, we might want to use maybe, you might want to maybe perform some sort of custom operation on maybe could be some categorical, not even category, but it could be a summary table. So assuming that we had this table that not even by the way, we might want to perform some aggregate function that aggregate technique that is custom to a summary table that works best. So instead of using maybe the normal sum, max, average functions, you might have your own operation that's suited for your use case. Then we can use group by as well as the apply function to do both, to achieve what you want. So in our case, we could decide to define a function that will perform what an aggregate function would do, but now it would perform a specific technique. So in our case here, we might want to calculate the total stock value, assuming this is a data set that contains products information, including information about stock value or stock information, quantity, as well as unit price. And when you multiply both, that will give you the unit, it will give you the unit value or the value of that particular product. So we would define a function that allows us to do that. We can also then later onwards decide to define also a function, not even just once we've defined a function, we will apply that function to our summary table to the group by operation that we'll use to create our summary table. So for instance, here we are using the group by function or method to specify that we want to group by category, but then perform some aggregate function so that the values on the right hand side are based off for furniture. What is the total unit stock value, total stock value for the category that is mentioned, maybe furniture, for lighting, etc. And that's what we do here. We perform that operation. We use the apply method to apply that function that we've created, and we use reset index to have a data frame output. We store the summary table there, and we specify the new column names, category, then total stock value, using this particular operation. I think we've done this early in the past, and then we display the total stock value for each category. And there you have it. This is this total stock value for, maybe the particular institution or entity that you have. Right, pause the video and then work on the challenge. All right, in some cases, we might also want to perform maybe some aggregate function, apply some aggregate function to a specific column in our data sets. And that might help us have maybe some new column that contains information that helps us to answer a research question. So for example, if we have the price here in USD, we might want to have a new column that maybe is in euros, that would help us answer some research questions. So to perform maybe that conversion with that example, we could decide to create a custom function that converts the value that we have here to euros using the appropriate formula which we have there. And then we once we define that function. We apply that function to the column, the respective column of our interest, which is price, and we store the output of that operation inside the price column, and we display the output. Right, and you can see on the far right, not on the far right, where is it? Oh, sorry. So we did here, we actually replaced the original USD columns column with the new ones for price, with the new values for price. So price here will be updated, but it's important to just have just the separate columns. It wouldn't hurt in many cases, especially for analysis. Right, pause the video and then work on the challenge. All right, moving on, data type conversion. So in some cases, we might want to convert the data types that we have in our data set, assuming that we had a data set here, products data set, and when we print out the respective data types, this is what we get. Maybe we might want to convert maybe the price column from integer to float, which we do here. And also the weight column as well to maybe integer. So what we might want to do is to use the as type function from Pandas, and we apply it to the column that we want, but then we specify inside that function the data type that we want to convert to. Say for our case, we want to convert the price column to a float data type and the weight column to an integer data type as shown. So yeah, that's it, and we display the output. All right, pause the video and then work on the challenge. Okay, so that's it with regards to this challenge. We hope that you are able to get the most out of this learning experience. And if you did find some value, be sure to give this video a thumbs up, and that will tell us let's continue just doing what we're doing. Or, you know, it just means continue producing more of such learning experiences. And if you'd want to be informed when we post such future learning experiences, be sure to subscribe. And all the best in your learning journey. Bye-bye.